All right. My name still remains the same. This is another set of experiments under physics, which is heat transfer. This is we have a lot of apparatus in front of us that has different functions, which I will explain them. Okay, let me start by this. This is our beaker. It is used to hold some quantities of liquid when you want to heat it. And this is our Bunsen burner, which a heat will be provided through, they will connect it through a gas so that the heat will be hitting this attached to this beaker that carries some liquid attached to it. This is our measuring cylinder. It is used to measure the volume of liquid. This is our test tube holder, and this is our test tube. This is used to hold the test tube. That is the reason why it is called a test tube holder. Now, the next one is this is a thermometer. It is used to measure the temperature of a body. While this is our lens, this is our salt. A salt, maybe zinc, yeah. If you want to perform any experiment, it depends on the kind of salt. Or then we have a stopwatch. It's used to read the time, because at the end of the day, you might be asked to plot a graph with temperature against time or time against temperature. It depends on the nature of the experiment. Now, after knowing that, this stopwatch is we have seconds, that's the bigger one. The little one is minutes. So they might ask you to 5 seconds. That means when heating it, you will check the temperature when the liquid is being heated, maybe after 5 minutes, and you will check the temperature when the body is cold. So at the end of the day, they might ask you to plot a graph of time against your temperature. It depends the way the case may be. Now, what is the principle guiding this experiment? It is heat transfer. And what is heat transfer? Heat transfer is a process of transferring energy from the higher body concentration of a reservoir to the lower body concentration of a reservoir. Then this heat transfer is being divided into three. That means it has three modes of heat transfer. We have conduction, and we have convection, and we have radiation. Let me start by conduction. Now, conduction is a transfer of heat, is a transfer of energy from one molecules to another by a direct contact. Then we have convection. But before defining this convection, that is the reason why under this conduction, you see a woman frying akara. Yes, the heat and the spoon holding to fetch this akara, there is going to be an handle. Yes, then the contact, which is the definition is talking about, as it's touching the oil, there will be this heat that will be transferring with this metal. But due to the handle on it, the heat will not be penetrating to her hand. All this process, or the example, is governing under this conduction, which is heat transfer, one of the modes. Then we have another one, which is convection. Is a movement of heat by a fluid such as water or air. Now, unlike what we have been observing every day in our house, when you want to take a tea, especially if you are using aluminium cup, an aluminium or silver spoon. So when this heat is very, very hot on this aluminium, you'll notice that the heat everywhere, both the handle of the aluminium will be hot, will be heated. The same thing with the spoon that will be put inside the aluminium. It will still, heat will be also being transferred to this aluminium spoon or silver spoon. That is the principle governing this convection under the heat transfer. Then the last one, which is the radiation. Radiation is the transfer of heat by electromagnetic waves. That is, if you want to define it in that higher manner. So it is also another medium of that heat transfer. So that is it under that. So as I've said earlier, I said the most important thing, precaution too, is having its own those things that you want to avoid in order for you to achieve a good result or obtain a good result. Those are the precautions that is needed. When the experiment is going on, you can bring out a lot of precautions.